In this video, we'll go over the basics of Bolt, its features such as flow graphs, state graphs, and variables, and how to begin using it within your project. For this, we'll simply need Bolt, which is now a part of Unity and free on the asset store, as well as a few game assets, which we've included in the link in the description. With that said, let's begin by going over the basic installation and setup of Bolt. To download Bolt, simply go to the package manager or the asset store and click install or download and import it into your project. Once Bolt has been successfully imported into your project, you should automatically be introduced to the Bolt setup wizard. If Bolt was successfully imported and for whatever reason you don't see the setup wizard, we can access it by going to Tools, Bolt, Setup Wizard. With the setup wizard up, click Next to go to the naming scheme window. For this project, we'll use human naming. However, if you're more familiar with writing code and proper syntax, you may feel more comfortable with the programming naming to get a more precise naming convention. For the time being, we'll simply click Next for the Generate Custom Inspector, Assembly Options, and Type Options. However, the more you use and feel comfortable with Bolt, the more you'll feel comfortable with specifying the options in each of these windows. Once Bolt is finished its initial setup, feel free to click Close or explore the online documentation manual. Before we begin developing our interactive elements, let's first go over the various features and tool sets that can be found within Bolt. Let's set up the different windows or panels we'll be using with Bolt. First, in the Windows drop-down, click and open Graph. In Bolt, you utilize and use the graph for everything you'll create. Since this will be such an important part of your Bolt project, we recommend you dock this window and make it a forefront part of the layout. Next, bring up the Graph Inspector. Much like its name implies, when items are selected in our graph, the Graph Inspector will allow us to inspect details about them. Lastly, we'll open the Variable window. The Variable window will allow us to create, alter, and view the variables in our graph, project, or scene. Once we have all our Bolt windows up and placed in the Unity editor, we recommend you save your layout, which will allow you to quickly and easily access your Bolt layout for use in future projects. Bolt contains two different types of graph we can take advantage of: flow machines and state machines. Throughout this project, we'll show you how to use both. However, for this example, we'll use a state machine. So add a state machine component to the game console game object. So, what is a state machine? A state machine can best be described as a very compact way to represent a set of complex rules and conditions. So essentially, states represent various types of behaviors for a given object or mechanic. An easy way to look at it would be in terms of a door or a treasure chest, for example. When the chest is closed, it's in its closed state. When it's open, it's in its open state. And the in-between, while it's opening or closing, is its transition or transitional state. With that said, to begin, we need to first create a macro file to store and save our graph data, or embed the graph and data within the game object or prefab. Since this is simply an example, we'll embed the graph data within the game object. At this point, we should now see the basis of our state machine in Bolt. By double-clicking on the start state inside our graph, we can see the flow machine inside. For those of you that have used flow machines in Bolt, the easiest way to think about a state machine in terms of how it's used in Bolt is simply thinking of states as containers that house individual flow graphs. Something to note, at the top of the graph, Bolt gives us breadcrumb trails, and we can use this to go in and out of our different states. If we exit our start state inside of our state machine, if we right click on an empty area in the graph, we can create 3 different types of states. We can create a flow state, a super state, or an any state. An any state allows a state to be activated through a transition at any point during play mode or gameplay once the transitional condition is met. To begin, let's create a super state. A super state is a state that can house other states and is a great way of housing and organizing macros that will have multiple unique state machines. Once we have the state created, right-click the super state and click Toggle Start. At this point, your super state should now be highlighted green. This is Bolt's way of indicating that this state will automatically start once play mode is entered. Next, delete the start state by selecting it and pressing the delete key. Then rename the super state to Game System Super State. To rename a state, select it and inside the Graph Inspector at the top, type the name into the title text box. Once the super state is renamed, double click the state or right click to open the super state. Within the super state, we can see our default start state. Something to note is, when outside of our state, we can see the event or events that are inside of that state's flow graph. Before we begin, let's first go over the logic we want to create. In this demo scene, we simply want to allow the player to open and close the door of the game console by clicking on it. That said, we know we'll need at least 2 states, one for the door opening and one for the door closing. So right click anywhere inside the empty graph and select Create State. We'll rename that Opened and we'll create another state and name that Closed. We'll also need some way to store both our collider and our animator since we'll be using them in multiple states, which means we'll need to create at least 2 variables. For those unfamiliar with working with variables, variables are used to store information to be referenced or manipulated throughout our graph or project. If we bring up our variable window, we can see Bolt gives us access to Unity's various variable types, in addition with several kinds of variables which mainly determine how we want the variable stored. We have graph variables, which are variables set to be located only in that particular graph. We have object variables, which are variables that can be stored throughout graphs on that particular object. We have scene variables, which are variables shared across any graph in the scene. Application variables, which are variables shared throughout scenes in our open project. And lastly, we have save variables, which are variables which values are stored after the application is closed. Let's create 2 object variables, naming one Game System Collider and the second Game System Animator. In Bolt, to create a variable, simply type the name in the variable name input. Once our variable is created, we can assign our variable a type, as well as placing in a value once our type is selected. With our variables named and created, let's change our Game System Collider variable to a collider type, and let's move our Game System's door joint into its value. The Game System door joint has the collider for our Game System door. When we place it in the value, Bolt immediately took the component that matched with our value type. For our Game System Animator, let's set that as an animator type. And let's move our Game System Parent object for its value. Once again, Bolt used our Game System Animator for the value since our value type was an animator type variable. Since our game console door will start closed, let's remove our start state and right click on our closed state and set that to toggle start. Let's now make a transition from our closed state to our open state. To make a transition, we can simply right click on our state and select Make Transition. We're then given a line and an arrow from our current state to the state we'd like to make a transition to. To make a transition to that state, we simply need to left click on that state while our transition arrow is active. Once a transition is made, we're then given a transition graph in the middle of our transition. Currently, even though we've made a transition, there is nothing in our state or transition graph to trigger an event to transition from our closed to our open state. Let's open our transition graph. Currently, we can see we don't have anything connected to our trigger transition event. However, we want to use our game system collider to trigger our transition once the player clicks on the game system door. To do this, we'll first need to create an on mouse down event node. To create nodes in Bolt, if we right click, we can see our unit and unit search box. Our unit search tool allows us to go through the various nodes that we have access to within Bolt. So let's go into our events and into our input, and we want to get an on mouse down input. If we go into our graph inspector, we can see our description for that node. We can see in our description our input target is the game object that's listening for this event. So for our input target, we want to use our game system collider node. Within Bolt, there are several ways to get access to the variables that you can create. If we right click within our unit and unit search box, we can type the name of the variable and we can see the various nodes that we have access to pertaining to that variable. Since we're looking for this variable to input into our node, we want to choose our get node. Additionally, with our variable window up, if we drag our variable within to our graph, we can see that our variable is automatically set to a get node. We can also change our variables to the other variables that we have in our variable graph. Additionally, we can change to our different kinds of variable states, such as our scene variable and application variable, to quickly get access to different variables that we have in our different lists. Let's connect the output of our get variable node into the input of our on mouse down event node. Let's now connect the output of our on mouse down event into the input of our trigger transition. If we leave our transitional state, we can see that we now have the event from our graph represented in the icon for our transition state. Before we continue, let's hit play and test our logic so far. So we could see the moment that we click on our door collider, we're automatically transitioned to our next state. With our transition now working correctly, let's go into our opening state and assign the logic to make our console door open. Let's first remove our update state as well as our on exit state, since we won't be needing those. If we go into our animation controller for our game console, we'll see that we have an open and a closed door animation. So if we look inside the transitions in our animator controller, we can see that to trigger our open animation, we need to set our isNestOpen to true. Alternatively, to get our door to close, we need to set our isNestOpen to false. So within our open state in Bolt, we simply needed to trigger our animator to transition to our open state in our animation controller. So within the open state in Bolt, inside of our unit search tool, we need to get the set boolean by name and value node. For our name, we want to use our isNestOpen, and for the value, we're going to set that to true. We'll also need to connect our animator variable for the target input for our set animator bool node. And let's connect our on inner state event into our set animator bool node and connect our game system animator variable into the target of our set animator bool node. Let's also copy all of our nodes by selecting them and pressing Ctrl+C, or we can also right click and go to copy selection And let's go into our closed state. And we'll delete all of our nodes that are currently in our closed state. And let's paste our nodes within our closed state. And for our closed state, we're going to set that value to false. Let's also make a transition from our open state to our closed state. And let's go inside of our transition and let's copy the original transition we created and let's paste it inside of our new transitional event graph. So let's now go into gameplay mode and test our new test scene. So we can see if we look at the top that both our states and our transitions are working correctly for our open and our closed.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, and free game asset giveaways.